There are many miles of undiscovered areas beneath the crust we can't even come close to. Scientists found what appears to be underground mountains buried inside the mantle. Our planet is divided into 3 layers: the crust, the mantle, and the core. The crust is where 8 billion people, trillions of trees, and millions of animals live and thrive. There are also different types of crust in the land and the ocean. The oceanic crust contains unique rocks and is denser than the land crust. We all see how the Earth is divided and color-coded to show the crust, mantle, and core in textbooks. But there are also special layers in between that not everyone talks about. The mantle is divided into the upper and lower part, which is the transition zone. Since the mantle acts as the geological recycling center, the plate tectonics don't only move side to side, but up and down. It's actually why all the volcanoes appeared. The magma spews out to the surface or even underwater, and then sinks back down and repeats. The transitions go down 250 miles and then 410 miles. And in this bottom layer, scientists keep discovering the hidden landscapes. The mountains in the mantle are more rugged and much larger than the ones on the crust. Scientists found a mountain range with peaks higher than Mount Everest. Some of them are as high as 600 miles. When the continents were still landlocked together, there may have been some hidden lands now underwater. Theories suggest that Iceland used to be part of a larger microcontinent, Icelandia, which connected present-day Iceland with Greenland and Scandinavia. The idea digs even deeper to a greater Icelandia, which includes Britain. But after the split, these bigger lands sunk with everything in it. There are also theories about New Zealand being part of Zealandia, a hidden microcontinent within the same region. So it could be that these mountains used to be part of old Earth that are underground over the billions of years of natural occurrences. But still, it isn't very likely. One theory is that these underground mountain ranges could be leftover slabs of rock that descended from the surface to the transition zone from the moving of the tectonic plates. As they sink, the large pieces break down into smaller ones, and as they compile over the millions of years, they form what appears to be underground mountains. Since the mantle is the geologic recycling zone, it's likely that the rocks down there used to be part of the surface. They weren't large pieces of land that got hidden, just like dogs hide bones in the garden, but it takes way more time to hide mountains. Some parts of the mantle appear to be smooth, while others aren't so much. The parts that have a cluster of rocks could contain hidden elements in the underground mountains. The smoother parts don't have much seismic or volcanic activity, while the rough parts do. The best way to study those underground landscapes is to wait for an earthquake or a volcano eruption to happen. Seismologists can observe the Earth's interior with special scanners, just like doctors use ultrasound to examine a patient. They can even see minor details and not huge chunks of rocks. A strong enough earthquake can send shock waves to the Earth's interior, even through the core and back up to the surface. Depending on where they occur, seismologists can observe and study the intensity of the waves as they move back and forth. On smooth rocks, the waves can travel in a straight line, but once they reach a rough area, the waves tend to scatter. The temperature and composition of the materials can make the waves move faster or slower. But this info isn't exactly accurate and won't contribute a lot to the actual data of the underground mountains. So by analyzing the scattered waves on ships and utilizing the Earth's magnetic field, scientists can figure out everything they need to know. But these studies are only good enough to figure out the interior in today's state, not how the Earth changed over the past 4.5 billion years. However, scientists are certain that mantle material still dates back to the beginning of Earth's original formation. The question, why not just dig a hole to the center of the Earth and see what's going on down there, might seem logical. The deepest hole humans have dug so far is the Kola Deep borehole in the Russian Arctic that goes more than 40,000 feet deep. The locals claim they can actually hear screaming coming from below. It took almost 20 years to drill as far as they went. but it's literally merely scratching the surface of what's underneath. They dug about 1/3 of the crust, which is only 0.2% to the center of the Earth. Getting there is beyond us, just like trying to reach the sun. No human can handle the amount of pressure down there. Going down the Mariana Trench, the Earth's deepest point, requires special gear to withstand all the immense pressure. It'll cost a fortune to build that tech to get us to the center of our planet. Evidence of diamonds buried deep in Brazil shows that everything we do on the crust's surface can affect things miles below, even towards the mantle. Scientists dug up 6 diamonds that could hold tiny mineral grains. As they're called in the mineral world, these inclusions have a chemistry composition where they originated deep in the Earth. Typical diamonds are formed at depths less than 125 miles in the upper mantle, where it's extremely hot. The high pressure and boiling temperature down crystallizes carbon and creates diamonds. But humans can't dig all the way down there. They mine them by detecting where a deep volcanic eruption happened that expelled these diamonds to the surface. These eruptions occurred millions of years ago, when dinosaurs used to rule the Earth. They shot out the diamonds that were in the mantle and are now embedded within the cooled-down volcanic material. That's where people mine them. But these special diamonds found in Brazil originated from a much deeper point than usual, which can further help scientists study the depths of the Earth. They can extract these inclusions and analyze them in a lab to tell where exactly these minerals come from. In the lab, scientists study inclusions, each just 15 to 40 microns wide, less than a quarter width of a human hair. They found out that they contained many types of minerals found in volcanic rock on the surface. The carbon composition of the magma from the surface is much different than the ones deep in the Earth. What's crazy is that these diamonds with special inclusions can only be found 435 miles in the lower mantle. With only a few samples of them found, we don't know what else lies beneath us. It's possible that those mountain ranges underground, taller than Mount Everest, can have traces of diamonds all around, which would prompt excavators to dig them up and saturate the market with them. These diamonds are less flawed than the usual ones and might even come in many sizes. It's possible to see diamonds as large as a car or as small as a grain of rice. There might even be new diamonds with different chemical compositions than the ones we find near the surface. The largest diamond in the world is the Cullinan, which can fit in the palm of your hand. It weighs around 1.3 pounds and is 3,100 carats. It was found in 1905 in South Africa. For anything to exist on Earth, you need carbon. In a nutshell, the carbon cycle is when plants and algae release carbon dioxide into the atmosphere or dissolved in water through photosynthesis. It's converted into carbohydrates and stored as fat. Later on, carbon dioxide is released into the atmosphere through breathing, which the plants benefit from, and the cycle goes on. Scientists claim that there might even be a carbon cycle in Earth's interior. The oceanic crust has a lot of carbon sediment that could mix with the upper and lower mantle layer. But there still isn't enough evidence to support this. The deep diamonds might be the key to popping open that theory. Only time will tell.
The coldest part of our planet, Antarctica, keeps surprising us. Take a look at this waterfall named Blood Falls. Reddish water falls from the white ice. Scientists concluded that the color is related to iron. The water coming from the glacier oxidizes and rusts when it's exposed to oxygen, and the red color occurs. Step on Mount Gandic. It lays eggs. Well, maybe not real eggs, but the stones certainly look like dinosaur eggs. That's why the mountain got its fame. Let's call them stone eggs, formed in one part of the mountain over 500 million years ago. Interestingly, this phenomenon repeats once every 30 years. Eggs come out in various sizes and shades. The stones appear on the surface of the cliff. A study made in the area has revealed that the composition of the stones of the cliff isn't similar to other parts of the mountain. Here, calcareous rocks rule. They're more prone to erosion. They ripen off day by day. It took 3 decades for the stones to get to the egg shape. Yet, it's still a mystery how these rock formations can be so perfectly spherical and smooth. According to scientists, every stone egg has an organic core. They're made of shells, plant remains, fish teeth, and skeletons. Maybe this has something to do with it. Gulu village is close to the stone eggs. Locals believe that these eggs are sacred. Villagers associate it with good fortune. In fact, nearly every family has one of these eggs in their house. Unfortunately, there are only about 70 eggs left, so if you want to see them, you gotta hurry up. The Richat structure is a circular geological phenomenon in the Sahara Desert near Mauritania. It's made out of rocks in layers, and these layers look very much like rings. No wonder the unique structure even got NASA's attention. Up from the sky, the geological feature seems to be swirling and spinning. Scientists are still not sure how these rings got there. Some say it was an asteroid impact. Many others believe that it was a natural geological process. To them, the Richat structure is an uplifted and eroded dome. Geologists often classify it as a domed anticline. The scientists discovered that the rocks at the center are older than the ring-shaped outer rocks, so it seems like the stones have been eroded to flat rock layers. Anyway, there's no valid explanation for this phenomenon, and the 28-mile-long mystery of the Sahara is still to be solved. Number 4 is Rapa Nui, or Isla de Pascua, but I bet you know it as Easter Island. Yeah, it's got 3 names. It was discovered by Jacob Roggeveen, who actually never intended to look for that island. He just casually landed there one Sunday. That's where the name comes from. Jacob was supposed to find Terra Australis. Disclaimer, it's not Australia. This one never existed and was nothing but a hypothetical continent. Plus, he wanted to peek at Davis Land, which was believed to have once been seen by Edward Davis, the pirate, not Edward Davis, the saxophone player. Jacob failed at that too, though nobody ever saw that island except for the pirate Davis. Jacob may have failed to discover some lands he wanted to, but he discovered Easter Island instead. This is an island and special territory of Chile, located in the southeastern Pacific Ocean. It's on my list because nearly 1,000 stone statues called moai were found there. They were created by the Rapa Nui people. Nearly all statues represent gigantic heads, but there are also a small number of figures kneeling with their hands over their stomachs. Each statue represented chiefs or other important members of Easter Island society. To curve those statues, the locals used volcanic stones that were softened. Our next stop is the gateway to the underworld. Nah, don't worry. This is just how people labeled Darvaza gas crater in Turkmenistan. This giant natural gas crater has been there for 5 decades. This crater is continuously burning gases. The president of the country wants experts to find a way to extinguish this continuous firing pit. This site was created by people accidentally in 1971 while working on a natural gas project. Ever since then, the flames have been on, and it's become a tourist attraction. Mysterious constructions are sometimes built in our era, too. We don't have to go millions of years ago to long-gone civilizations. Edward Leedskallen single-handedly built a structure called Coral Castle in Homestead, Florida. He didn't use any large machinery. He carved and sculpted more than 1,100 tons of coral rock in 28 years until 1951. It's a mystery how he managed to do it all by himself. Leedskallen sculpted the sedimentary rock into different objects, such as walls, tables, chairs, a fountain, and a sundial. There's of course a legend behind this mystery too. He was inspired to build the structure after being abandoned by his fiancée on their wedding day. Uh-oh, runaway bride. Well, he wanted to prove his love to her and the world, so he wanted to do something extraordinary. Well, he definitely nailed it. Now, let's talk a little bit about the mystery of the Namibian fairy circles. There are millions of circular patches in hundreds of miles, ranging from 10 to 65 feet in diameter. They're called fairy circles because they look like a fairy or an otherworldly creature made them. These are essentially oval-shaped soil surrounded by grass. There are a lot of local beliefs surrounding the creator of these marks, yet science says something else. Biologists and mathematicians have been puzzled by the mystery of the Namibian fairy circles for decades. There is more than one theory to explain this phenomenon. Here's one popular theory. The water is limited in the desert, so plants compete to reach the water. Some plants expand and thrive into a patch, but smaller plants nearby cannot get the necessary water to live. In the end, some vegetation disappears, and the remaining ones stay at the patch's edges. That's why they form such regular distant gaps. What if I tell you that there is a hill in Leh City, India, where instead of rolling downwards, things roll uphill? It's an optical illusion. The road looks like it's a sloping hill because of its surrounding landscapes, yet the road actually goes down. These kinds of hills are called magnetic hills or gravity hills. Scientific explanations vary. The most common theory says that the hill has such a strong magnetic force that it can pull cars in the vicinity. Now, how about seeing some flaming rocks? Yanartash spread over an area of over 3 square miles. The place is located on a rocky mountain in southwest Turkey near the town of Çağrıoğlu. Yanartash got its name from its appearance. It literally means flaming stone. The rocks have been flaming for at least 2,500 years, and they'll probably keep burning for the coming decades. The mountain where the rocks are is an inactive volcano, so it's full of tiny fumaroles that release gases such as methane. The gas ignites when it comes into contact with oxygen and creates the flaming effect. And by the way, back in the day, sailors used the flames as a natural lighthouse, as it's really close to the sea. Today, it's more of a tourist attraction, though. Hikers love it too. Now, walk on this frozen Lake Abraham in Canada. In winter, the frozen water gets filled with ice bubbles. It looks magical, but these white orbs aren't that safe. They consist of flammable methane gas. Ew. Beauty can be misleading. The next one is from Racetrack Death Valley, USA. There is a dry lake bed with moving rocks. Now these odd rocks look as if they've been pushed or dragged by someone or something. They leave both a trail and a mystery behind. The force behind all this is now understood. Surprise! It's the wind and some ice. Scientists say the wind pushes the rocks during brief windows when the soil is covered with ice. Now, I can't help but notice that many mysterious things on Earth involve stones or rocks, or methane. Which one of these phenomena is your favorite?
Attention! Attention! Residents of all countries and cities of the world! A massive asteroid is approaching the Earth! Now its speed is several times greater than the speed of sound, and each day it accelerates even more. Once it enters our solar system, it will fly past Uranus, Saturn, Jupiter, and Mars. The gravitational fields of these planets will also accelerate the asteroid, and our planet will be the final destination. A collision is inevitable. According to scientists, a meteorite the size of Mount Everest can destroy the entire planet. The disaster will happen in 350 days. There's panic in the streets. People buy and build bunkers. Scientists and astronomers from all over the world were assembled to find a solution. The only way to avoid the collision is to destroy the space object. Yeah, a powerful rocket can split an asteroid into hundreds of thousands of pieces. In this case, a meteor shower will hit the Earth, but it's better than the complete destruction of our home. In less than a year, people build several powerful rockets. Then, using the best telescopes in the world, astronomers create a unique guidance system. And now, we just have to wait for the asteroid to get into our solar system. All the people start moving to one continent with top-notch bunkers for everyone. The damage from the asteroid is impossible to predict, so it's better to hide people in one super large safe place to wait out the collision. The moment has come. The asteroid passes by Uranus. The speed increases. Now the colossal space object moves only 10 times slower than the speed of light. Scientists launch rockets into the air. The asteroid flies past Saturn and destroys a part of its ring. The asteroid's trajectory is changing. It flies past other planets through a twisting path, picks up speed, and now heads towards the Earth. The rockets leave a long trail of fire behind and reach the speed of sound. They're getting closer to the asteroid. Near Mars, a collision happens. The rockets hit the target. The asteroid explodes and splits into millions of particles. All the pieces fly in different directions. The Earth is saved. At this moment, the Earth's satellites record a huge burst of energy. a small part of the asteroid is headed towards Earth. It's tiny, about the size of a grain of sand. But the explosion accelerated it, and now the grain of sand is flying towards the Earth at a speed of 185,000 miles per second, which is 99% of the speed of light. At this speed, the grain has almost the same destructive power that the entire asteroid had. It's approaching the moon. A few more seconds, and the grain of sand will hit our planet. All the people are waiting with bated breath. The grain gets such incredible power because of the laws of physics. The greater the speed any object is, the more mass and energy it has. When the grain of sand reaches a speed close to the speed of light, its energy and mass begin to increase dramatically. You can't even see this tiny grain of sand, but inside, it has the mass of an entire continent. If the grain reaches the speed of light, its mass will be infinite, and then a black hole will appear. In this case, all living and even inanimate things on the planet will disappear. Trees, seas, and oceans, all the cities, countries, and continents, air, sound, atmosphere, any molecule of the Earth, everything will be absorbed by the incredible gravitational force of the black hole. Then, when there is no trace of our planet, the hole will take over the moon. The gravitational force will grow and absorb other planets of the solar system. Soon, it will reach the sun. Our star will split into thousands of strips like spaghetti and will emit a tremendous amount of energy. This could trigger the birth of a second black hole, but fortunately, we only have 99% of the speed of light, which changes everything. Also, no object that has mass can reach the speed of light. The grain of sand enters the Earth's atmosphere. From the outside, it looks like a blinding meteor that pierces the sky. The grain heats up, passing through the layers of the atmosphere. Clouds within a radius of 100 miles around are burning up. The sky becomes crystal clear. If you look at it in slow motion, you can see the air is ionized because the air molecules are split. In nature, this process occurs during lightning flashes. Our sun also has ionizing energy and disinfects the air. The meteorite leaves an ozone hole behind it. So now, this place is not protected from space radiation and ultraviolet light. The grain of sand flies straight into the center of the Southern Ocean. The closest continent to the explosion is Antarctica. The air around it warms up and mixes with the cold temperature of the ocean, creating hurricanes. As soon as the grain approaches the ocean surface, the water starts boiling. The temperature and energy of the grain are so huge that the water evaporates, but the vapor molecules are instantly burned up. Thousands of gallons of water just disappeared from the face of the Earth. The grain flies down for the first few feet without touching the surface as the water evaporates before it. Then it falls into the ocean and creates a powerful explosion. Hundreds of millions of gallons of water foam and boil because of the hot temperature. The entire ocean within a radius of 100 miles is illuminated with a bright light. The ocean depths, where sunbeams have never been before, are almost as transparent as the water at the bottom of a pool. The wreckage of old sunken ships splits into atoms because of the powerful explosion. Unknown sea monsters and giant squids that live in the dark are afraid of the bright light and swim away. Then, finally, a grain of sand touches the seafloor and penetrates deep into the Earth's crust. If it reaches the Earth's core, the planet will most likely explode from a burst of incredible energy. Fortunately, this is not going to happen. The resistance of the ocean and the ground slows down the grain and takes its energy away. It provokes a slight shift of tectonic plates, and there's more to come. Huge waves form and spread throughout the ocean. The blast wave creates enormous tsunamis. Imagine throwing a small rock into a puddle. The same thing happens to the ocean. Huge waves are approaching the coastal cities. Fortunately, people were evacuated from there, but the damage caused by one grain of sand will cost hundreds of trillions of dollars. Houses are destroyed, roads are flooded. After a while, it starts raining with hurricanes. Ocean water vaporized by the grain forms into huge storm clouds. The wind drives them to the continents. And then, after the tsunami, prolonged rain begins, flooding entire countries. Several days later, natural disasters are still here. The temperature of the Southern Ocean has increased by several degrees. The water is boiling at the collision site, melting the Antarctica glaciers. Millions of icebergs are melting away, so the water level of the world's oceans is rising. The edges of some continents go underwater forever. Thunderclouds reach the Sahara and other deserts. The shift of tectonic plates causes earthquakes on some continents. Volcanoes are awakening. The sky is filled with volcanic ash. It will take months for all the ashes to settle. In the beginning, it creates challenging conditions for life on Earth. Plants and all living things don't receive enough sunlight. In trees and seaweed, photosynthesis is disrupted. Oxygen production stops. It's getting harder to breathe. The air that has filled the planet's atmosphere is slowly running out. People have to adapt to new conditions. They build new cities both on the land and in the ocean. They create plantations with artificial lighting for photosynthesis production. Fortunately, all the problems end when the ash settles. Inside the volcanoes, there's hot magma flowing. It may come in handy as it's rich in chemical elements and minerals. Together with the ash, nutrients fall to the ground, and the soil is now well fertilized. Plants, trees, fruits, and vegetables grow incredibly fast and produce a lot of new oxygen. The Sahara is filled with blooming flowers now, and it looks more like a meadow with flowers, not a desert. The grain of sand just renewed the planet instead of destroying it.